So we are given this function h of x, and we're asked over which interval does h have a positive average rate of change. So like always, pause this video and have a go at it before we do this together. All right, now let's work through this together. And to start, let's just remind ourselves what an average rate of change even is. You can view it as the change in your value of the function for a given change in the underlying variable for a given change in x. We could also view this as, if we want to figure out the interval, we could say our x final minus our x initial. And in the numerator, it would be the value of our function at the x final minus the value of the function at our x initial. Now, they aren't asking us to calculate this for all of these different intervals. They're just asking us whether it is positive. And if you look over here, as long as our x final is greater than x initial, in order to have a positive average rate of change, we just need to figure out whether h at x final is greater than h at x initial. If the value of the function at the higher endpoint is larger than the value of the function at the lower endpoint, then we have a positive average rate of change. So let's see if that's happening for any of these choices. So let's see, h of 0, this endpoint, is going to be equal to 0, if I just say 1/8 times 0 minus 0. And h of 2 is equal to 1/8 times 2 to the third power is 8. So 1/8 times 8 is 1 minus 4. So that's going to be, this is -3. And so we don't have a situation where h at our endpoint, at our higher endpoint, is actually larger. This is a negative average rate of change. So I'll rule this one out. And actually, just to help us visualize this, I did go to Desmos and graph this function. And we can visually see that we have a negative average rate of change from x equals 0 to x equals 2. At x equals 0, this is where our function is. At x equals 2, this is where our function is. And so you can see at x equals 2, our function has a lower value. You could also think of the average rate of change as the slope of the line that connects the two endpoints on the function. And so you can see it has a negative slope. So we have a negative average rate of change between those 2 points. Now what about between these two? So h of 0, we already calculated as 0. And what is h of 8? Well, let's see, that's 1/8 times 8 to the third power. Well, if I do 8 to the third power but then divide by 8, that's the same thing as 8 to the second power. So that's going to be 64 minus 8 to the second power minus 64. So that's equal to 0. So here we have a 0 average rate of change because this numerator is going to be 0, so we can rule that out. And you see it right over here. When x is equal to 0, our function is there. When x is equal to 8, our function is there. And you can see that the slope of the line that connects those 2 points is 0. So you have 0 average rate of change between those 2 points. Now what about choice C? So let's see, h of 6 is going to be equal to 1/8 times 6 to the third power. So let's see, 36 times 6 is 180 plus 36. So that is going to be 216. 216 minus 36. 216 is 6 times 6 times 6. And then if we divide that by 8, that is going to be the same thing as, this is 36. And then we have 6/8 of 36. So this is going to simplify to 3/4 times 36 minus 36, which is going to be equal to -9. You could have done it with a calculator or done some long division, but hopefully what I just did makes some sense. It's a little bit of arithmetic. And so at h of 6, we have our function is -9, and then h of 8, and I'll draw a line here so we don't make it too messy, h of 8 we already know is equal to 0. So our function at this endpoint is higher than the value of our function at this endpoint. So we do have a positive average rate of change. So I would pick that choice right over there, and you could see it visually. H of 6, when x is equal to 6, our value of our function is -9. And when x is equal to 8, our value of our function is 0. And so the line that connects those 2 points definitely has a positive slope. So we have a positive average rate of change over that interval. Now, if we were just doing this on our own, we'd be done, but we could just check this one right over here. If we compare h of 0, we already know is 0, and h of 6 we already know is equal to -9. So this is a negative average rate of change because at the higher endpoint right over here, we have a lower value of our function. So we'd rule this out, and you see it right over here. If you go from x equals 0, where the function is, to x equals 6, where the function is, it looks something like that. Clearly that line has a negative slope, so we have a negative average rate of change.